And at long last, we are ready to answer some questions around the impact that weather has had on flight delays. We're going to take a couple of different approaches to this analysis, and the first approach is going to be to create a pivot table that allows us to identify the weather conditions that were the greatest contributors to weather delays coming out of Chicago O'Hare in January of 2017. If you are not already on the flight data worksheet in your workbook, please navigate there and then make a selection anywhere within the body of the table. Next, navigate to the Insert tab on the ribbon and then to the Pivot Table button. Click the button. Let's quickly double check that everything in the Create Pivot Table dialog box is as we would expect it. And the answer there is yes, it has correctly identified the flight data table range. We do want to insert the pivot table in a new worksheet, so we are good here. Let's click on OK. And now we have a new worksheet. I'm going to first double click on the worksheet name, and we are going to name this worksheet Delay by Weather. And then we are ready to dig in. If you are not seeing the pivot table fields list over on the right hand side of your screen, then first try to click somewhere in the body of the pivot table area in your worksheet. That should make it appear. If for some reason it doesn't appear, assuming that you've made a selection within the body of that pivot table area in the worksheet, then you should see a pivot table tools area on your ribbon. You can click on the Analyze tab, and over in the Show group on the right hand side, there's a button for Field List that allows you to toggle that on and off. Once you can see the field list, what we need to do is scroll down and find our Weather Issues field that we created and check the box to place weather issues on rows. We're going to withhold any analysis until we have the table built. For right now, if you see all of the different weather codes in your pivot table on rows, you're in good shape. And the next thing that we're going to do is we're going to add 3 different values to our pivot table. I'm going to scroll down toward the bottom, and I'm locating that actual delay field that we created in a previous video. And I'm going to drag 3 copies of it down to the values quadrant in the fields pane list. Initially, all of the values are going to be the same. It has applied the count descriptive statistic to each of the columns. And as it turns out, we do want a count because that's going to tell us the number of flights that are associated with each one of our weather conditions. So that's going to give us a sense of the volume of flights that are being affected. But I want to change some formatting and clean up the presentation a little bit. So for the top instance of actual delay in values, I'm going to click on the drop down, go to Value Field Settings. I'm not going to change the summary value, but I am going to change the field name to number of flights. And I'm going to change the number format. So click on the number format button. I'm going to format it to number, 0 decimal places, using the 1000 separator. Click OK to close out of the format dialog box. Click OK to click out of the value field setting dialog box, and now my number of flights is correct. Let's move on to the other 2. So the second instance of actual delay, instead of getting a count of the flights, I want to know the total volume of delay, keeping in mind that all of the delays are expressed in minutes associated with each one of these weather conditions. So we will click on the drop down arrow, go into Value Field Settings. This time we are going to change the summary statistic to sum. We're going to give it a custom name of total delay, in parentheses min, so that we know our unit of measurement, and apply the same number formatting as we did before. So click on number format, change the data type to number, 0 decimal places, using the 1000 separator. Click OK. Click OK again. And that takes care of total delay. Last but not least, we want to edit the third instance of actual delay in the value quadrant. So we'll go to value field settings. This time we want to see an average so that the delays will be adjusted by the number of flights associated with it. So we'll select average. The custom name that we'll give it here is average delay, again with min in parentheses to show the unit of analysis and with the same number of formatting applied. 0 decimal places, use a 1000 separator, click on OK, click on OK. And now we see the delays in terms of minutes. So for raw data analysis, we've got the nuts and bolts, but let's do some additional work here. In the pivot table tools group up on the ribbon, I am going to select the design tab and I'm going to make two changes here. First, I'm going to change the report layout to show in outline form. And I'm also going to apply a different style. Click in the styles group and I'm going to select the pivot style medium 18. I want to apply some conditional formatting to convert this to a highlight table, but there's actually some additional work that I want to do to limit the data that's being presented before I take that step. As you look at the weather issues, you can find no issue in the middle of the pack because right now it's sorted alphabetically. You can see that the vast majority of flights, even in January in Chicago, no weather issue was reported. The vast majority of flights in and out were not impacted by weather. Since we are focusing on weather delays, though, I don't want the no issue category to skew my results. So I want to filter no issue out of the analysis. To accomplish that, I'm going to come click on the filter drop-down arrow that's at the right of the weather issues label in the upper left-hand corner of my pivot table. Just going to uncheck the box for no issue. While I'm here, I'm going to do a couple of other things. First off, I want the table to be sorted in a way that identifies the weather issues that on average had the highest weather delays associated with them. So I'm going to select the option for more sort options, then click the radio button for descending order, and then click in the drop-down box to change the field from weather issues to the average delay. Click on OK, and you can notice that changed the sort order. I'm also noticing that it threw back no issue back in the mix, so I'll fix that here in a minute. But let's take one more step and let's limit this to the top 5 weather delay conditions. So I'm going to click on my drop-down arrow again. This time I'm going down to filters, to value filter, and I'm going to hover over value filter, get the submenu, and then go to the bottom of that where it says top 10. And I want to show the top 5 flights, the top 5 items by not number of flights, but by average delay. Click on OK. And when I do that, I'm now seeing the weather conditions that most directly impact delays. Let's add some formatting to make the numbers at the extremes really stand out. I'm going to start by highlighting all 5 of the values in the total delay column, clicking on the Home tab on the ribbon, selecting conditional formatting, then color scales, then the red, yellow, green color scale that's going to make larger values show in red, indicating that larger values are bad, so that we can see where our problem areas are. I will step through that process again for average delay. So highlight the column, go to conditional formatting, color scales, red, yellow, green, and now we've completed the work in this table. So what does this tell us about the adverse weather conditions and their impact on overall flight delays? Well, Not much unless you have the data dictionary, because these codes can be a little difficult to understand. Lucky for you, I have a PDF of the data dictionary for this data. BLSN space BR. Well, if you put these codes together, BLSN is blowing snow, and BR stands for mist. So, misting, blowing snow. Doesn't sound like any weather condition I would like to be caught in the middle of. And indeed, it is the condition with the highest delay, with an average delay of 58 minutes. But the interesting thing to point out there is that while it is the highest in terms of average delay, when you look at it for total delay, it is one of the smallest, and that's because it only impacted 10 flights. This is a bad weather condition, but it isn't a common weather condition. You know, if instead you look at misting snow, which is number 4 in terms of average delay, but is by far the largest in terms of total delay minutes, and the number of flights, I mean, clearly the fact that that many flights were impacted by it indicates that that is a weather condition that occurs much more commonly. So while on average it might have less of an impact than some of the other conditions on this list, its frequency means that it's impacting more flights and subsequently more people. So, in the bigger picture of, does it appear that weather-related issues impact flight delays? Yes, they do. And the common conditions that occur at certain types of year, like misting snow in Chicago in January, are the ones that have the greatest impact. But it is also worth remembering that by far the largest number of flights weren't associated with a weather issue at all. The importance of putting data in context and thinking about it in terms of the bigger picture is a key component of data analysis, and hopefully will be one of your key takeaways from this course.